Here's another example from what for us would be lesson 19, question 7. And you can read the question on the lesson, but here's what it says. We have a chain that's suspended between two poles. And naturally, it would dip down like that. And when that happens, that arc right there that some flexible object would make if it was suspended between poles is called a catenary. And let's say that it's the truth about this one, that the equation from that, as it would appear imposed on a graph like it is y is equal to 2 hyperbolic cosine x over 2. Okay, so that's the scenario. The question is, how far apart are these two poles? Okay, we happen to know they're each 6 feet tall, and one is so far to the right of the y-axis, and the other is equally far to the left. And we don't know what that is. But if they're 6 feet tall, and this chain as it's suspended like so has that equation, how far apart are the poles? Okay, now I didn't know what to call that. We don't know it, the number n right there, which is the location of this one, but if you knew that, it would be 2 times that. If this spot right here is at 10 on the x-axis, then that's at negative 10, and their distance is 20. So that's how I thought to do it, is if I could just find that, I'll double it, I'll have my answer. Okay, so about how do you find that? Well, this point would be n for x, because it's right above that one, and it would be 6 for y, because it happens to be 6 feet tall. So if I could just say y was 6 right there, and I could solve for the x, I would know where that is, and then I would just double it, and I'll have my answer. So how about this? We'll set it up and solve it this way. We'll say 6 is equal to 2 times hyperbolic cosine of x over 2. And what is that doing? That's like saying that we're going to let y be 6. And we're going to solve for this x right there. Okay, about how to do that. Let's go ahead and divide out the 2. There's no need for that. And we say 6 by 2 is 3. And then we have hyperbolic cosine x over 2. Okay, so we get there. And how might we solve that? Well, I guess we could use our calculator, but I told you there might be reason not to trust the answer that we get. So we'll solve it step by step, okay, without our calculator. And so here goes. Let's say this is 3. And about that, what should we say that is? Well, I might have to look it up, but I provided the formula for hyperbolic cosine. And here it is. It's e to that power plus e to the opposite of that, so negative, all over 2. That was it. Okay, and I see I have a 2 again, and I'll multiply by 2. I'll clear it. I'll get 6. And that would leave me this. Also, I realize that that's really a fraction. And now I'm here, okay? Well, so we can solve this just like we solved the example that's right before this one on the lesson. At this point, we'll take that whole equation, we'll clear this fraction out, like so. And here's what we get: 6 e at power x over 2. And what about these two? How do you multiply like things? You add their powers, and if you add their powers, you get 2x over 2. So you'll get this, okay? And then here, if I multiply those, I get just 1, and that's where I'm at. Now, I would think that this one, like the last one, would be a quadratic equation. And so I will aim to solve it that way by getting 0 on one side, moving everything else the other side. So here's what it looks like. Okay. All right. So you get there. And about that, here's the issue. Is it quadratic? A question mark, is it? Well, is this thing, if you square it right there? Yeah. Let's do, let's write it like this just in case. So look, if you square that, which is this thing in the middle, you do get this. All right, so we can tell that is quadratic because you take this and you square it and you get that. And this would just be me verifying that. All right, so I've made my point that it's quadratic. So about the answer, what I put on this side of the equation won't surprise you. I'll do what the quadratic formula says, negative b, or the opposite of the b, plus or minus b squared minus 4 times 1 over 2 times 1. But what goes over here, it doesn't give you the x necessarily. If it's quadratic, it gives you whatever is right here. Okay, so what this is giving me as an answer to out of that is what e to the x over 2 power is. Okay, so now we're here, and we'll break that down. Let's see, so that's 32, so it's 4 root 2. Okay, over 2. And then that would say that e to the x over 2 is 3 plus or minus, and 4 over 2 is 2, so 2 root 2. Okay, so it looks like, just as you might expect with the plus or minus, you find an answer over here, like something that's positive, and then you find one over there. Just like it looks, you're going to find both of them. You know, there's this point, and then there's that point. But how do we get some final answer? Well, how would I solve if it says e to this power is equal to that number? I use logarithms at this point. Okay, so x over 2 is the logarithm base of e, which is natural log, 3 plus 2 root 2. Okay, I'm going to leave off the minus because I'm aware that there's both spots. I only need one of them. So I don't care for the purpose of solving this. I don't really care about that one. So I'll just find the one on the right. That's what this is. Okay, that's all we need after all. Okay, final answer then. I get x is equal to 2. Multiply that over here. Natural log 3 plus 2 root 2. Okay. So we get that. What were we going to do with that? That being my final answer to this original setup for my problem. I was going to double that. I have found that the location of that spot is at this place. That's what I figured out. And if I double it, well, that's, as I said at the beginning, that's how far apart these are. So let's give this. My final answer, if I take 2 times this, is going to be 4, because 2 times 2 is 4. Natural log 3 plus 2 times square root of 2. And I guess if everything was measured in feet, then that's how many feet they are apart. Okay, so if we get our calculator at this point, and do 3 plus 2 root 2, take the logarithm of that, multiply it by 4, then you'll get about 7.051 feet. Okay, so we'll get both of those. That one is perfect, and this one's rounded, and so it has a little bit of rounding error in it. Okay.